When you discuss dynamics, we are either discussing about the objects or the particles which are in motion. So to define the motion, we need certain parameters which will be help us to understand the type of motion. So first in this particular lecture, we'll be discussing what are those basic parameters required to understand the motion and how we can define the motion. So the first parameter that is need to be discussed is the position of a particle. Here we are considering the particles as a part of study. We are not considering the objects because we are not interested in the size and shape, not interested in the size and shape of the object. So even though we are dealing with the objects, we are considering the objects as particles because we are not dealing with the size and shape of the objects. So when I say the position of a particle, what does that mean? That at any instant of time, what is the location? What is the location with reference to datum or origin? So when I say that, suppose there is a car which is going in this direction, and now I want the position of this particular car at a certain point. Suppose if I want to find out the position of the car at 10 a.m. So to decide the position of the car, first we should know from where you are measuring, from where the measurement starts. And the point from where the measurement starts is generally called as origin or the datum. So when I say the car is at 10 a.m. at a particular location, suppose now I am rewriting this car as a particle, so I am not interested in the size and shape. So I am considering this is a car which is at point A at t equals to 10 a.m. Now suppose this car is traveling with certain velocity in this direction and it reaches a particular point B at time t equals to 10:30. So I am considering the A as the initial point of measurement, which is, if I consider this as the x-axis and y-axis, so this is the x-axis that I am considering, this is the y-axis that I am considering. So with reference to x and y-axis, now I am trying to figure out the position. So initially the object or the car was at A point at 10 a.m. So here I am considering t equals to 0 seconds. That means I am starting the point of measurement when the car starts moving in the forward direction towards B. So at a particular point of 10:30, that means t will be equals to 30 minutes. The object will reach at point B. Now if I want to know the position of the object at point B, I am considering the distance displacement traveled between A to B is the displacement it has traveled in the x direction. So I am considering this as x. So when I write the position of the object at time t equals to 30 minutes, so position at time t equals to 30 minutes is equal to x meter, right? So if I want to find out the displacement of this object, now there is a difference between displacement and distance. Suppose the object is at point A and it goes to B. So if the car goes something like this and it reaches the point B, the distance is the path traveled by the particle along like this. So this is the distance, and if I measure a straight line distance between A and B, this becomes displacement. So displacement is generally defined as displacement is equal to change in position, or it is the shortest distance between 2 points. Now when I say shortest distance, generally straight line is the shortest distance between any 2 points. So the straight line between A and B, which is a change in position, is the displacement. So the position when the time period is equal to 0 or at the starting point, I am considering it as the position is x equal to x0. In this case it will be 0, and at time t equals to 30 minutes, the position will be 30 meter or x meter, or it will be x meter. So now in this case the displacement is generally indicated as x, or sometimes it is indicated as s. It is one and the same. It will be final position x minus x0. So when I say a position, now suppose the object, again I am considering the y-axis and x-axis for the measurement. Suppose the object is initially at this particular point, which is, I'll consider it as C, and now it is reached the point D. Suppose from the origin, from the point of reference, the C point is at 5 meter, and from the origin the D point is at 15 meter. Now I am starting from C to D, so at time t equal to 0, the object will be at C, and at t equals to some t seconds or t minutes, the object will be at D. Now when I say the position, so x0, which is the point of starting of the measurement, the position of the object when t equal to 0 is 5 meter, so it will be x5, or we can write it as 5 meter. And when it reached a particular t second, xt will be equals to 15 meter. So this is how you define the position at a particular point of time. Now if I want to find out the displacement is generally final position minus the initial position. And based on this we can write it as xt minus x0, which is equals to 15 minus 5, so it is 10 meter. So this is the displacement that you are going to get. So this is how you define the position of a particular object at different time periods. So if I take one more example out of this, suppose again the object is traveling in a straight line, and suppose I am starting the initial point here. So I am considering the time period or measurement starting point is 0, object is at first point. Suppose after 5 seconds it reaches 10 meter, after 10 seconds it reaches 20 meter, something like this. Then the position with respect to this origin will be x0 will be, so if I consider this as 5 meter, then x0 will be 5 meter. At time t equals to 5, it will be 10 meter, and at x equals to 10 seconds or time period 10 seconds, the x will be 20 meter. So this is how you define the position. Now this is, we are considering only in the forward direction. Suppose the object is traveling in the leftward direction, then what will happen? Suppose if I take the origin again, and suppose the object is initially on the left hand side of the origin. So this is the origin where the coordinates are 0 0, x0, y0, and the object is somewhere here, and it is suppose minus 10 meter, and I am starting from this particular point, and the object has reached, after 20 seconds it has reached this particular point, which is suppose 35 meter. So this is when t equals to 20 seconds, and this is when t equals to 0 seconds. So the initial position of the object x0, that means it is the starting point from where you are starting the measurement, so it is minus 10. And when I am considering 20 seconds, x20, so displacement position after 20 seconds is 35 meter. Now if I want to calculate the displacement, it becomes displacement becomes x20 minus x0, which is 35 minus of minus 10, which will be 45 meter. So this is the displacement, which is the measurement of distance between these 2 points. So likewise you define the position and the displacement, which is very, very important in case of dynamics. How it is important, how we can find it out, we'll discuss it later. Next is velocity. So here we have discussed the position and the displacement, both are hand in hand. Now we are going to discuss the velocity. So velocity is generally indicated as v, and it is defined as displacement per unit time, or in other words we can say change in position with respect to time. So what does that mean? That suppose again if I take the same object here, and the object was initially somewhere here, and then it has reached to this particular point, so from it A to B it is traveling. So when I started the measurement t equal to 0, the object is at this particular point, suppose this is 5 meter from the origin, and in 10 seconds it has reached 15 meter. Now we have to find out in how much time it has reached or covered this particular distance. So for that, what we have to do is we have to consider the time period in this picture. So when I say a displacement or velocity becomes change in position. Change in position is x10 minus x0 divided by t minus t0. So when I write this, it becomes 15 minus 5 divided by 10 minus 0. So it becomes 10 divided by 10. So it will be 1. Displacement is in meter, velocity or time is in second, so it will be velocity, which is 1 meter per second. This is the velocity. Now to define this velocity, there are two ways of defining it. One is instantaneous velocity and another one is average velocity. So there is a difference between instantaneous and average velocity. So first we'll try to understand what is average velocity. Which is generally indicated as v. So when I say average velocity, as we have discussed in this case, the object is traveling from A to B, and now we have got the velocity as 1 meter per second. But we are not sure that this 1 meter per second is continuously same throughout this distance. It may be 2 meter per second at one particular point of time, or it will be 0.5 meter per second at the other point. But we know that on an average the velocity is 1 meter per second from A to B, but we are not sure what is the velocity at certain middle points, whether it is 1 meter per second, less than 1 meter per second, or higher than 1 meter per second. But we know that the average velocity from A point to B point is 1 meter per second. So when you calculate the velocity for a larger time duration, it is called as average velocity. So velocity is calculated over a certain time period is called average velocity. Most of the cases V average is also written as V, which is, now since we are calculating for a certain time period, we have to consider both the positions, so it will be x minus x0 divided by t minus t0. Or if I now reduce the time period, that means I want the exact velocity which is at this particular point of time or at this particular point of time. So you can see that the time period in this particular duration or in this particular displacement is very, very small. So generally in mathematics we indicate a very small time period as dt. So suppose at this particular initial point of this, the time is t1, then at a very fraction of second, that means it is a fraction of 1 second as well, I am adding the time period as dt. So within these two time periods I am trying to find out the velocity. So the time is very, very small, which is going to be very, very small. So what I am going to do is I am considering the time period as very small, very small element, very small duration. So because of that, what happens is the time period t minus t0 is very small, so it becomes dt. Or we can say that suppose the object is at time period t1, it is at this particular point, and in a very small period of time dt it reaches to next point. Now if this will be t1 plus dt. So now if I find the time difference of this, what will happen? It will be t1 plus dt minus t1, so it becomes dt, which is a very small period. Now, and the distance it covers is also very small, so I can consider this distance as dx. Now here remember that the dt that I am considering is very small as it is tending towards 0. That means it is going to be 0, but it is not going to be 0. It is not going to be 0. It is not equal to 0, but it is going to be 0 because I am dividing it into a very, very small element. So in this case, if I find the velocity in this particular distance or in this particular time duration, it is called as instantaneous velocity. Instantaneous velocity, which is generally indicated as v instant. So now v instantaneous velocity is when the time period is very small, that is dt tending towards 0, the velocity is called as instantaneous velocity. We will be discussing this in detail again in later part of the syllabus, but right now we are just dealing with this. So now the velocity instantaneous can be indicated as, instead of writing x minus x0, since the distance is very small, I am writing it as dx, and instead of writing t minus t0, since the time period is very small, I am writing it as dt. So v instantaneous becomes dx upon dt. But in most of the cases that we are going to solve the problems, v is generally, in both the cases, we either take it as x minus x0 upon t minus t0, and we'll consider this as equal to, because we are considering the average velocity over the time period, it becomes dx by dt. So both the equations will be using interchangeably so that it will be easier for us to solve the problems. So this is how we find out the velocity or the instantaneous velocity or the average velocity. Next is acceleration. Which is generally indicated as a. So acceleration, as we have studied in physics, that acceleration is defined as change in velocity with respect to time. So in this similar manner as we have discussed in the velocity, we have two again parameters. One is average acceleration, which is final velocity minus initial velocity. Final velocity minus initial velocity divided by time, or final time minus initial time. So here we can write it as, we'll indicate the final velocity as v, and u as initial velocity. So when I write the average velocity, v average will be v minus u divided by t minus t0. But again, if I reduce the time period to a very small value, I can write this as dv by dt. So this is average or the accelerations. Here you can rewrite this instantaneous acceleration as dv by dt, but we are not dealing with the average and instantaneous, we are dealing the average values. So I can write this as a equals to v minus u divided by t minus t0, or I can write it as dv by dt. So now we are considering acceleration as change in velocity divided by time, or dv by dt. So these are the three parameters which are very much required for understanding the concept of dynamics. So from this particular point of view, we'll be continuing with the actual part of mechanics, which is types of motion, and how we are going to find out the equations for types of motion. Thank you.